Follow? Any adventers here? All right. I'm going to get started. Day 5. Advent of Code. Sorry, Advent of Bash. Not to be confused. Let's see what we got. Day 5. If you give a seed of fertilizer, you take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more to you like a farm. A water source? Island Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water for a few days, weeks. Oh no. His face sinks into a look of horrified realization. Hey, Meep. How's it going? I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Island Almanac just arrived, and we're having trouble making sense of it. The almanac lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are reused in each category. That is, soil 123 and fertilizer 123 aren't necessarily related to each other. Oh, geez. For example, seeds 79, 14, 55, 13. Seed to soil map. What? Seed to fertilizer map. Fertilizer to water map. Okay. This almanac starts by listing which seeds need to be planted. 79, 14, 55, and 13. Yeah. Where does 79 come up again, if at all? Okay. The rest of the almanac contains a list of maps which describe how to convert numbers from a source category into a destination category. That is the section that starts with seed to soil map, describes how to convert a seed number to a soil number. So lets the gardener and his team know which soil to use with which seeds, which water to use with which fertilizer, and so on. Rather than list every source number and its corresponding destination number one by one, the map describes entire ranges of numbers that can be converted. Oh no. Ranges are my enemy. Ranges of numbers. Each line within a map contains 3 numbers. The destination range start, the source range start, and the range length. Okay, so this is saying 50 and 51 map to 98 and 99. This means that the source range starts at 98 and contains 2 values, 98 and 99. Destination range is the same length, but it starts at 50 and 51. We know that the seed number 98 corresponds to soil number 50, and that seed number 99 corresponds to soil number 51. All right, not so bad, not so bad. Yeah. Any source numbers that aren't mapped correspond to the same destination number. Okay, so it just doesn't change. This is going to be hard to do in Bash without like actually dropping down into imperative programming. Hey Brainoid, how's it going? With this map, you can look up the soil number required for each initial seed number. Wait, what? I thought this was our input. What is this? Oh. Oh, you're doing the honest jam? Are you doing another whatchamacallit? I forgot his name. What's the character's name? Oh no. Gondo? Is that his name? Yeah, Gondo. Okay, what are we actually solving for here? Gardner and his team want to get started as soon as possible, so they'd like to know the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. I'm sorry, what? What is a location? Oh. Wait. Okay. So we just go through a bunch of translation layers. So it's effectively the same thing, just repeated a number of times. And then at the end, we'll get a location. And then we want the lowest location number that corresponds to any of the initial seeds. Okay. That's not making another ambitious game. Nice. Oh, I see. They made it really big numbers so that it's annoying to think about. Cool. Um, I think we're gonna have to. So are these always in the same order? Yeah, so the labels don't really matter. It because we're just going through these sections in order. So really it's like read a chunk, do a translation, and then read another chunk, do another translation until we get to the bottom. Let's make our input.txt, which is this. And let's make our sample.txt, which is this guy. Hey, how's it going? So this is gonna be like... Let's make a parse function. Hey, Rinks. And we're gonna read one line off the top and then echo it, and that's our whole program. Can we do that? We can do parse sample.txt. Okay. Get the first line. How's it going? Good. We're doing some advent of code. Basically, we have to take this text and turn it into a number. And then we have to take this text and turn it into a number. Sounds pretty easy, right? You could just... We just gotta get the right number. Yeah. No big? Yeah, yeah, yeah. Alright, here's our numbers. And then... What, I guess we'll replace the spaces with new lines. To get a nice list. We can say seeds is this. Okay. Can we do this? Will that work? No, okay. The new lines are baked in. Interesting. What if we did it like this? No, it's not any different. Sure. What do we need to parse next? These big chunks. Hmm. There's a couple ways to do this. But I think the easiest and most understandable is just going to be to do it in a loop. Mm. Do I want to do that? Or, we should use the power of bash here, right? I need to look up. Said replace new line. There's a way to do this because we don't want to use tr because we need to do multiple. There's this horrible thing which I've done before. Where we just do this. That gets rid of all the new lines. If we want to only get rid of double new lines, we can do this. Uh-oh. No, that worked. And now what we can do is we can replace these with some symbol, like an @ symbol, for example. And now we can get rid of single new lines, replace them with a bar, right? See where I'm going with this? You probably don't. I don't either. And then what we do is we bring back the double new line. So we say, get rid of the @ symbol, but let's just do one new line. Uh-oh, what did I do? Oh, I'm missing one of these. Okay, that didn't work. Wait, this just needs to be a regular sed. Right? Yeah. So now each line is one of the things. Kind of. We might need to do a read first to make that a little better. That pipeline is cursed. No, but look how nice it makes the output. We go from this to this. It's gonna make our lives easier. We're gonna do a grep. We're gonna do this. Oh, now that output is looking good. You could write that pipeline. I'd love a simpler way. Oh, I thought you were gonna offer a suggestion for how I can make it better. Awk's cheating. No, it's not off limits, but it's a slippery slope. Because once you do an awk, said select instead of said remove. Not sure what that means. I wonder if this would work though, actually, now that I'm thinking about it. Oh yeah, this works. You're selecting numbers? No, okay, I'll walk you through what this is doing, right? Let's put a cat here. So, step 1 is no, don't worry. Step 1 is we're grep ving for this, right? And what this does is it just gets rid of these lines that say what they're mapping, because they're actually not important. They're just there to make you feel better. So we're getting rid of those. And then this next line is it's doing two things because I just combined it. It's replacing double new lines with an @ symbol, and then it's replacing single new lines that are left over with a pipe. And then this one is turning the @ symbols back into a new line. And we end up with this. We can turn these off for now. And so this is like each row is a set of translation ranges. Yeah, it's not too bad. You just have to do this weird thing to make said like read the whole file in one go. I forget what this exactly says. I think it's broken down here. This reads the whole file on a loop and then does commands on it. I don't understand how, but it does that. Yeah, normally. If we want to be really bad, we can put this one back in here too. There. Does that make you feel better? let's indent it so that it fits on one line. Perfect. All right, good. So we do that thing. And now what? So we got to figure out what to do about these ranges. Anyone know what to do if my microphone isn't working? Well, I have no idea. I'm sorry. We're going to do another sed because we're adults and we're allowed to have a few seds. We're going to find a 0 to 9 space. A few of these. Okay, this didn't work. Oh, the plus needs to be here inside. Okay. What the heck? Star? Huh. Do we need like dash E for this or something? Hmm. Mm. Okay, what does one of these mean? Match one or more of the preceding token. So does that have to be exact? Huh. No, the token would be the 0 to 9. No? Yeah, that matches. So what's not matching about this? If I just do 1, does it work? No. Uh... That's strange. Why broken? So that works. Are they not spaces or something? I'm pretty sure they're spaces. Do I need to escape these spaces? It didn't really help, like... Like, that matches. Eh... Said replace number. Why are they escaping the plus? What the fuck? I didn't know you had to do that. Okay. All right. So what was the thing? It's like the destination Uh, destination range start, source range start, and a range length. And we have to turn this into some kind of math expression. So if it's in the range, we need to subtract the second number. Sharing my joy with you. After 4 days of learning programming, I launched my first 100% functional calculator. Gives 70% chance of giving the correct calculation. If you add 7 plus 8, it says the result is between 5 and 18. That's pretty good. It does sound 100% functional. So we subtract the source range start and we add the destination range start, but only if it's in the range. Well, that's a cool fish you got in the champion spot right now. Oh, up against my axolotl though. Oh damn, I'm getting owned. Your fish OP. I think we're gonna end up writing the most horrifying set of all time. Seems like what's happening here. We're gonna... Alright, let's start with some parentheses. It's good to have parentheses. So let's make some token. Like the seed number goes here. It's an @ symbol. So if @ is greater than greater than or equal to the source range start, which is the second number, so 2. If it's greater than or equal to that, and it's less than yeah, it's less than 2 plus 3. Oh, what the fuck happened here? What did we do? The third capture group is huge for some reason. Oh, what? Hold up. Okay. What is... Okay, we're back to here. What is 1? Okay. There's 2. Okay. What is 3? Uh-huh. What? Is it the and symbols? Oh, okay. I think if it follows. Um, this is getting complicated fast. Let's get rid of these spaces to make it a little more more readable. There we go. Now it's making sense. So that tells us whether or not it's in the range, right? Now we can multiply by our conversion. So at minus the source range start, which is 2, plus 1 is the conversion. And we should be looking good. The one thing we have to handle is when it's not in the range. When it's not in any range. I think we're going to have to do that in a post-processing step, unfortunately. But this is looking good. We're going to replace the bars with plus signs. And yeah, that's our little thing. So we have to run it through. Let's call this translations. Or maybe even translators. Yeah. I like that. And let's agree to never touch that again, because that looks pretty awful. So we need to run our seeds through it. Um, let's just say 69 for now. Okay, so we can put a number into it. Now we need an outer loop that's like let's change this to translator. Okay. Okay. We're pumping all of our seeds through the translator, which should give us a number. Um, we can do some new lines there. If the translation uh what did we start with our seeds as? Yeah, that didn't work. I think this line is wrong. I tried to be cute. Okay, why isn't this working? Oh, don't look at that. We already agreed we weren't gonna look at that. Stop it. Let's echo one translation and then exit 0. Why are we losing? Is this one of those cases where it's like I say seed equals translation and then it doesn't actually happen? No, it's happening. 81 0. Okay, so it is getting changed. So is this right then? Uh, oops. So these are our locations. What are we supposed to get? 81. Oh, wait. 82, 43, 86, 35. Great. Then we need the lowest one, right? So we just get rid of this. We get rid of this. We just have these numbers. We need the lowest one. So we go sort n. Head 1. There we go. 35. Input. Okay, that's a different number. And we get the right answer. Bash will never steer us wrong. Literal goated language. This is proof that you don't need a type system to write correct programs. You just need pipes. Pipes are really the answer. All right, excellent. Let's go to part 2. That did take us a little longer than yesterday. I'm a little scared how out of hand these are going to get. Everyone will starve if you only plant such a small number of seeds. Rereading the almanac, it looks like the seeds line actually describes ranges of seed numbers. Oh dear. The values on the initial seeds line come in pairs. Within each pair, the first value is the start of the range, and the second value is the length of the range. So in the first line of the example above, 7914, this line describes 2 ranges of seed numbers to be planted in the garden. The first range with seed number 79 contains 14 values. Now, rather than considering 4 seed numbers, you need to consider a total of 27 seed numbers. Consider all of the initial seed numbers listed in the ranges on the first line of the almanac. Let me look at my input real quick. Are you kidding me with these numbers? Excuse me? It took me 10 minutes to run part 2 today. I don't think you maybe got the optimal solution. I don't think Bash will survive if I rip that many numbers through it. Like what is this number? It's like 235 million. When she scratch or what? I think we have to be more clever to get this. I don't think we can brute force this in this language. Fuck, I hate being clever. Yo. I can't. I don't know how we can be more clever though, because there's so many translation levels. Do we? Do we just try the brute force version? I think there's just absolutely no way that it'll work. My poor computer's gonna melt. I think the only way we can run the brute force version is if we generate a script that just does it in a pipeline. But I still think there's, like, is this number even bigger? Like, these are ridiculous bonker numbers. These are 100 millions. A bunch of them. This is billions of processing. This was only 56 million. There has to be a faster way. What am I missing? So the lowest... What am I trying to do? It's the advent of code. You have this example where these numbers go through this map. I go through a bunch of maps. So like you translate the seed to a soil number, you translate the soil number to a fertilizer number, fertilize to a water number, water to a light number, light to temperature, temperature to humidity, humidity to location. Then you get a location number. And now they're telling me instead of having 4 seed numbers, I'm gonna have 4 billion. Yeah, I was just thinking that, like, what if we do it? What if we walk backwards and we do like a search algorithm through like these steps. So we sort this, and then it gets. I think the ranges on these are big too, though. So it doesn't really help because we would have to. It's like you have to find like the intersection of these ranges. So like this one, the lowest it goes is 0. So you could start at this and see if it intersects any of these ones. And it might hit multiple because that's a thing. Maybe that's okay. Because then we just sort those. Well, we don't even need to sort them. We would just... Anyone hit the hell that is part 2? Yeah, we're on it right now. Let's copy our part 1 to part 2. Switch back to sample. All right. So this is where I want to maybe start. So we start with the dest and map to the no, we map source to dest and then source to dest. So we're like let's draw what we want to do here. Where's my here? So we want to identify that 56 is the smaller number. So we're going to take 93 and map it to, oh, fuck. No, it gets weird when it doesn't map onto one. So we almost need to like add another level to this that's like uh, so then we go through that one. That's so confusing. Then we chain this 93 over to one of these. I don't know. Probably, I think it's this one. And then we have to look where the 45 goes, which is this one. So is this not that bad? Maybe this is not that bad. But it's not just the start of the range, right? We need to find all of the ones that intersect. Because, like, this one's quite a big range. It goes from 25 to 95. So it technically overlaps all 3 of these. Uh, right? It's almost like a tree problem. Bash is not known for its tree parsing capabilities. How do you even represent a tree in Bash? Um, well, you can, you know, Bash is great at trees? Wait, teach me. Teach me, Warren. I can't, I lied. Well, that's unfortunate. Well, Bash has recursion, and recursion is all you need to do trees. So basically, what I'm saying is not a problem. But I think this approach is good because we're gonna walk our way up the chain. We're gonna get back to the seed ranges, and in theory, we'll have 2 cases, right? Uh, 2 cases. The first one is we get to the top and there's no matches. My handwriting's terrible. If there's no matches, then we go back to the start and we pick this one instead. The second case, there are matches, and we just have to pick. We have to find the smallest seed number, which would be. It's just the first number of. Well, no, it's not the first number. It's the first number that overlaps. Hmm. Okay, I think we need to come up with a method for determining like the intersection of ranges That's the uh doesn't this kind of crumble with this thing? No, that's what we're handling right here. Um because we know that because if we scan the mapping up to the next level, then we know that if it doesn't intersect, uh I guess we still have the problem. If it partially overlaps. Okay, let's think of all the different cases that can happen between two ranges, right? Say we have a red and a blue one. So one case is they're the same. Well, that's a bit of an edge case. Um, one case is that the red one is bigger than the blue one. One case is that the blue one is bigger than the red one. There's also a case where they're offset like this. There's also a case where they're offset like this. And the last case is they are not even fucking close. So there's 6 different cases. I guess one thing to consider is you could have like this where there's a little hole here. This would be annoying because that would map to the same number. Hmm. This seems hard to code. Trying to think of how to put this into code words. Just make the computer do the hard work and wait 5 minutes. I don't think it's gonna take 5 minutes. I have no idea how long it's gonna take. Although, using this idea, maybe there's some compromise between the brute force and the because we might be able to do this in one scan, you know? What do I mean by that? I mean, we start from 0 and we work backwards through our translation list, and then we see if it's a valid seed. And then we just, if not, we just go up by 1, right? Like, this is also a big number. How big do these numbers get? Okay, these get into the billions. Going by 1 was too slow still? Damn, really? I could see it, yeah. Oh, but one thing we could do... Well, we could be smart about how many we jump, right? Well, I guess, I don't know if we can. Can we? Like, okay, let's walk through the trivial example. We start at 56. Because that's the best possible outcome. And then we turn that into a 93. So that's what it maps to. And then when we get here, we're like, well, shit, 93 is just not even in here. Uh, this is a hard one. I want to look at the leaderboard for this one. Wow, people took a while on part 1. Oh, wait, no, this is part 1. This is part 2. Okay, people took a while on part 2. What was the fastest somebody got it? Somebody got it in 8 minutes? Damn. They definitely didn't do the brute force solution. I can tell. Yeah, binary search is when you're working with like sorted data. Hmm. 8-minute person must have seen someone stream it and then made the... No, it's... It's 8 minutes within it getting released. They didn't. It's not 8 minutes from when you start. Yeah. Means they were the first person in the world to submit the right answer. How am I doing? I'm struggling, I'll be honest with you. This is a hard problem. What to do? We're working on Advent of Code. We're struggling. Let's go back to the tree idea. We're basically what we need to do is turn because the important thing here is that we know it has to fit into this bucket coming from the previous one. Have you done part 2 yet? No, we're working on it right now. We know it has to come from here. So what that means is that we can modify this red range and cut it in half. So our search space is bounded. And then we have to like find out what these 3 smaller ranges are and recurse up the tree. I think this can work, but I really don't want to code it in Bash. That's the problem I'm facing right now. You can do it. I hate you. We knew it was gonna get bad. I just didn't know it was gonna happen so soon. All right. I think step one, I want to sort. I want to sort each of these by their source, no, their destination range start. Okay. So these are our ranges. Um which we can pipe into tack to flip over. Tack is of course, the opposite of cat. Because we want our tree to, we want it to be a, top to bottom sort of search. Bottom to top is weird. Um, and we can pipe into sort sort map, which is going to be a function that I'm going to make right now. It cats. But that's not what I want it to do. I want it to replace these with these. And then I want it to sort n. Oh, wait a minute. Oh, no, that's not what I want. Hold on. Part 2 is pretty tough, huh? Yeah. Okay. I want this to do... Let me just do this too. Okay. Yeah, what happens? Why has that gone and happened? I see. I don't see. Is it reading the new line? How can we fix that? there. All right, my tree is sorted. Now I just need to traverse it. Uh, great. We could do what? For a level in levels. Uh, I'm scared. um, wait, why is it doing that? Uh-oh. Does that not work? Bash loop through lines in variable. Should I just do it with a while loop again? I guess so. Okay. Now we've got one range. This is where we're starting. Uh and we need to so we need to map the source of this range. So the 93 what if we just did like oh wait, what? First, last, first increment, last. Oh, so we'd have to do like ugh. That's not even right. Maybe -1. But if we do that, we're printing out like hundreds of millions of numbers, so I don't think we want to do that. I think we want to basically let's I did actually. I found it off stream. The solution was to not work on it for a day and then just it magically started working and I have no idea why. So that's good. I'm glad that happened. Um let's so let's say we go from 93 to 96. This is our well, let's say 97. This is our range. When we go up a level, we find that there. Well, we look at the first one. We say, is 93 in the range of 0 to 1? No. Is 93 in the range of 1 to 70? No. Well, we can't even do that though. We can't just find one. We have to find the ah we find the intersection of two ranges. It's if hmm. This is hard to verbalize. Right, because there's a lot of cases as we discovered. Let's see, do these have anything in common? Well, there's 3 cases where the red range starts inside of the blue range. So the red range needs to either... Oh, man. Okay, hold on. There's the blue range starts in the red range here, but it doesn't here. It does here. Oh wait, is this it? These are the 2 cases? Either the red range starts inside of the blue range, or the blue range starts inside of the red range. That means they intersect. If neither of them start within each other, then it's no... I don't understand why it's 3... I guess technically this is yellow and it's pink. This is like the... This is why it doesn't look right. Okay, so 1, 2, 3. But what does it mean for one to start inside of the other? It means that the start is greater than or equal to the other start, and less than the end? Jeez. This is brutal. Flowchart it. I think it's easier to write it in code. So we essentially want the intersection. I guess if we consider the fact that the ranges don't overlap, do they? Can they? I feel like the source ranges can't overlap because that would not make any sense, but maybe the destination ranges can. think the destination ranges can. Can they? Maybe they don't. It looks like they don't. I'm hoping they don't. So we find all of the intersections with the next level up. Okay. Now what? We need the start. Can you do read ABC? 1, 2, 3. Yeah. So it's destination, source, length. And then we'll just change these to B. This is 2. So we're taking the destination. No. Taking the source of A, mapping it to the destination of B. God. Is it easier to check if two ranges don't intersect? That would be a case of, let's see. If they don't intersect, the end is less than the start, and the start is less than the start, or it's over here. Yeah, this is easier. There's 2 cases, right? We have, it's either fully outside on this side or it's fully outside on that side. So we can check that. If that's the case, what do we print out? Just nothing? Let's see if we can even accomplish that, right? So AE equals AD plus AL minus 1. BE equals B. And for this one, we use S. If AE is greater than BE and AD greater than BE, then echo no intersection return. Same thing is true if uh if AE is less than BS, otherwise let's just I don't know, print out intersect. Ooh. Next level equals levels. Next level levels J. Heck. Mm. Tree? Tree. Let's do this. Uh, okay. We're gonna do range, intersection, range 2. Syntax, error, and expression. Yeah? Okay. So it's like we thought. There's no interaction or intersection between those two levels. Uh, ranges. Hey, Scott. Uh, how do we even do this? Okay, no intersection, no intersection, no intersection, no intersection. Interesting. Hey, how's it going? How's your game coming along? We're trying to do Advent of Code, but it's pretty difficult today. I'm not sure I'm gonna get this. Your game is finished. Donkey already played it. Shoot. Part 2, yeah. Part 2 is rough. I'm feeling it. I think it's a tree problem. I'm pretty sure it's a tree problem. It's definitely a tree problem. Is it a tree problem? I don't know if it's a tree problem. Gotta go. Don't want to be spoiled. All right. It is the struggle bus. Solves this in 5 minutes. Well, I think you could brute force it if you used a faster language. I haven't tried, but I don't think Bash is going to be well suited for brute forcing this. So I'm trying to do it the right way, whatever the heck that is. Trying to find an elegant solution. Yeah. But it's like now I have to solve for the holes, and I don't know how to solve for the holes. Did I even do this right? Because it's like this is AD, but I'm supposed to be doing it the other way. So maybe I should be mapping these like range to range. Oh, but now it says they intersect. That's curious. um, this one definitely doesn't intersect either of them. Does it? No. Does this one? When are you going to do an advanced bash course? Hmm. Good question. This one's saying that 56 maps into... Oh, it did find an intersection. Look at that. Hey. All right, I do want this to be the other way, though, because it's going to drive me crazy if it's not. So we need to change all of these to say... S, D, S, D, D, S. Okay, back to where we were. So 56 to 37 intersects with 1 to 70. Yeah, that's true. Or not 56 to 37. That's 56 to 93. But now we want to modify. I've got it working on the test input, but fail on the full. Is yours a brute force solution, or is it a... What kind of solution are you going for? Mind if I ask a noob question? Go for it. I'll try my best. So basically, we want to clamp the. I also went with intersections independently with stream muted. Gotcha. You didn't derive it from my work of art here? We need to clamp B onto A. So we're gonna if. Let's keep these. I like these. If instead of using bash, why not program a CLI with a programming language to do the commands? Why not just program a CLI with a what? I don't understand the question. To do what commands? To a beginner like me, I'm just using bash to automate installing Linux packages. Why? So why would it be easier to like? I still don't understand. So you're using some package manager like apt. Um, yeah, it's a bit like um what's a good analogy? Programming SCLI is just more overhead. No, I mean Bash is the same as a C. It's like you're basically asking like, what's easier, using Bash or inventing Bash, right? Like inventing worse Bash. Like if your goal is to install a bunch of or to do like a bunch of Linux commands, Bash is really good for that because the language is made for that. Like it's definitely the easiest language to call other programs. But if you're doing something that's more complicated, like you wanna like resolve a dependency tree or something, before you decide what to install, then yeah, maybe it's better to write that in like Golang or something, for sure. Or if you're building something for the JavaScript ecosystem, maybe you write it in JavaScript. That way it's more platform independent, right? Then you can get it to run on Windows, Mac, Linux, no problem. But if your goal is to run some terminal command or a bunch of them, I don't know. Seems like a good idea to use Bash. It's just easier, right? Like I would recommend using it when it's easier to use it and appropriate. So like what I'm doing is a bad example. This would be much easier to do in a different language. But we're doing it for fun, so that makes it okay. Exactly, yeah. Why would you write a CLI for your installing your packages when you could just write a GUI in x86? Like, I don't know. It's a weird question. So, let's see. We're mapping onto, I have to keep referencing the picture. The D. So if BD is, wait a minute. Okay, if it's less than AS, BD equals AS. To do update BS as well. Same thing here. If B if BE is greater than AE, BE equals AE, and we'll recompute the length. We'll say BL equals BE minus BD plus 1. And then we'll print all that out. So it's S or DSL. Okay. So our range, wait, L didn't get updated, but it should have. Um, this only happens if BE is greater than. Oh, I guess this should happen out here. Okay. Now we have to update BS. So we need to find out how much BD is changing by. Change equals AS minus BD. So that updates the range. Am I using Kitty? No, this is the Windows terminal. See? Don't swear at me. Sorry, this is the terminal. Is that better? W. I didn't mean to say Windows in front of you. I'm sorry. Okay, so look how cool this is. We've calculated the intersection of our ranges. We've smashed this one down. How about that part two? Are you still doing it too? I'm getting destroyed. I'm done but got wrecked. Did you brute force it or did you come up with something else? I'm trying to come up with something else because I don't think bash brute force is gonna be fast enough. Ranges? Okay, I'm trying to do ranges right now. You can see my hell that I'm in. Didn't use any clever tricks, just did the range math. Did you work from the bottom up? Just plan to do it in Rust with the brute force. Yeah, as long as we call the Rust code from bash, should be good. You started from the seeds heading towards the goal, if that's what you mean. Oh. We're working backwards from the goal. I don't know if that's faster or worse. I'm not sure what you mean when you say you did the range math. We have a problem though. I need to find the holes in my range, and I don't know how to do that. What was done to one side must be done to both sides. I need to figure out how to detect this little jerk. I don't know if I'm smart enough. Calculating all the ranges I need, doing all the lookups to convert them to the next set of ranges. Huh. I think it's the same idea. I started from a different side for some reason. Yeah, I'm basically doing the same thing. I don't know why I didn't think that I could do it from the we got down this path of doing it from the bottom. I mean, one way to know if your answer is good is did it run in less than, 30 seconds? If it did, you probably did pretty good. Snappy, nice. I looked at the numbers and I was like, yeah, brute forcing this is pretty out of the question. My computer's gonna go through like 2 billion process IDs trying to crunch this out. That's a no go. um, how do I detect a hole? I had that happen on day 3. I found bugs in mine after submitting. I was like, oh, oops. This seems like a headache. Not yet. We're getting close though. I think what I want to do is I want to take my trimmed ranges. So I have something that looks like this. It's all nicely chopped up. Uh, I want to start here. Actually, no. I want to sort my ranges so that we have red and then green. I want to start at my start number. We start here. We skip to the end of this range. We see if there's a gap or not between this one and the next one. If there is, we add another range to fill this up until the start of the next one. And we loop until we hit the end. And that'll fill in our problems. Once we have that, it really is just like we just need to climb the tree. And it's going to be great. But we need to pave the roads first. So let's get rid of this garbage. Um Let's see. Read, start. Uh, source, start, len. Uh, so the range intersection. We're mapping onto this one. So I want to sort. I'm just sorting in on these things. We can say dest end equals dest start. Oh, wait. No, we care about S. So let's say start plus len. Echo start end. Mm-hmm. So what is gonna happen for this one? We have a hey, thank you for the sub. Uh, send help. Do I want to put this in wait, what is this emote? Oh, it's a global. There's a global fish emote I didn't even know about. I got wrecked. Because we're gonna have to insert more things into this list. It's a huge jump from previous days. Oh, in difficulty for sure. Let's print it out and let's save it to an array. Declare a stuff. No, that's a bad name for a variable. New ranges. Oh wait, no, we're not gonna do this. And I'll tell you why. Because then our sorting isn't gonna work. So we have to do this. We have to do this post. This equals something. I've got too many overloaded terms here. Oh, shoot. Why did that happen? If RNG equals continue. Bye. Okay. This doesn't make my life easier, to be quite honest. Unless we just do it right here. We do our logic. We do like pointer equals start. Read ndnsnl from RNG. If if pointer not equal to ND paving. Okay, so in this case it is equal. After we put it in, we want to update we just need one pointer, right? We update the pointer to the end of our current one. So pointer equals ND plus NL. And then outside of our loop, if pointer is not equal to end, great. So what does paving do? Well, it just makes up a new range. It's gonna do it starts at pointer. $70, $70, $23, maybe. How do you print out an array? All right, you can just do this. Star? Okay, I might need parens around these. Seems to have broken it. Oh, there we go. Bash iterate array. IDK. New ranges. What the fuck happened there? Oh. Okay. Wait. Oh, okay. That was a weird bug. We weren't resetting our state properly. Okay. We're paving the road. We're doing the thing in the picture. We've solved the question mark. No problem. The next step is scary because it's gonna reveal the problems with this approach. And I'm I'm hesitant to just let it do its thing. Do we hmm. Where do we even stick our new loop? Because we need this to climb the tree somehow. um, I less than depth -1. Oh Jesus, what did that do? Um, so it's gonna climb the tree, but it's not. Zero, 0, 15. That doesn't seem like a real thing. 39,015. Where even is that? That's here. The problem is that we're using tree level. Which doesn't use the previous level. So it's like doing all this calculation and then it's not even using the information that it gets. Unless it is. How did this get a 52? What the fuck? It seems like it'd be the most cursed thing of all time. It's not going, it's not my favorite thing right now. I'll tell you that much. I think we need to do recursion now. But we can't really do that because we're in loop hell. I think this outer loop was a mistake, and I would like to retract it. But I think this might need to be its own function. Do the thing. Okay. And then right here, we just do the thing. It works. Not really. Oh. There we go. So it takes in ranges as input. And it looks up ranges in the next level of the tree. So instead of grabbing it like that, Let's feed it in like this. Why is it going and printed out twice? Uh-oh. What? Why did it print twice? Uh... Um... Oh, it didn't. Oh, that was... Wait, is this even... It's not doing the right level anymore. Oh, something is very wrong. Is there still data left? No. $56, $93, $97. Oh, wait, this is what it's... No. 56... What? Oh, it's printing to the end. It's not print... Okay. Let's change that. I don't like that at all, actually. Len. Okay. Okay. We're doing the thing. Uh... I wonder if we can do a cute little echo print L. What? Not echo. Function. Let's see. Indent equals 1 shift printf %s. How do we print the indents? Printf print n characters. Printf n repeated characters. You could do spaces. That's what I want. Uh, Oh, it works. Nice. Let's change that to I though, and then let's not print out these guys. Do the thing. J. I made infinite recursion. Oh shit. Too many files open. Alright. That was pretty good. Are we okay? Ooh, so that's not quite right. Uh I'm scared to run this. Yeah, I should be. Okay, so it says 62, 62, 4 a lot. Oh, I am noticing. We probably need to cap the, we probably need to say, like, uh, if I equals depth, then return. No, that's still making a mess. Okay, how about this? If it's greater than 2, we'll stop. All right. We got somewhere. Is it because we don't have local I and local J? I think we need to make everything local. I think this is important. Bash declare local. Local. I know, right? Local array. How do you do it? What? Okay, we're referring to bash stack on this one. Um, do I not do it on any of the local dash A? Okay. Okay, now we're getting somewhere. We're getting actual. Let's slap a local on this. Local RNG. Local input. Local IDK. I'm definitely gonna miss one and I'm gonna cry. How goes Advent of Bash? Terrible. Yeah. Have you done this problem yet? Also, thank you for the sub. This problem is hard. Kuvy man, have you done this? You're not smart enough to do ASC? Oh, come on. I believe in you. Yeah, this one is a big jump. You did this? Okay. We made a tree. My actual solution code was like 9 lines of Python and I have no idea what's going on here. Wait, what? Your solution for part 2? Day 5? I'd be very curious to see how you did that. So if we get to max depth, this is where we want to start checking our seeds. It's more like 13 lines. Did you just brute force it? Yes. How long did it take to run? What? It took 6 seconds to brute force? Those were big numbers. What do I do when I get to the... So I need to see the seeds again. 79, 14. Okay, so this is saying it's range from 79 to 92, 90, no, 93, 92, 92. So I need to do one last intersect check with the seed ranges. Which I'm realizing now I haven't parsed. There's a way to do this. Bash, paste every other line. How does this work? There we go. We got our seed ranges. So which one do we want to compare? We want to compare the source. So let's pad these with a 0. Oops. Okay, so we pad those with a 0. Is that right? Let's get rid of our print L for now. Um, so we still want to read all the ranges here. Oh, so there's just one. What's the raid message? Hello. Thank you for the raid. Did you... Okay. So we're doing Advent of Code. We're on day 5, part 2. Did you solve this? Because I'm having a heck of a time. You didn't? Oh no. I think we're close. I have a feeling we're close. But we are doing it in Bash. And so I'm a little bit overwhelmed because this is a lot more recursion than I normally do in Bash. We had a guest show us their solution. All right, no spoilers. Yeah, we're not doing brute force. Here's my diagram. You can dive into my brain and see what I was thinking. Basically what's going on here is I don't know. Something to do with there's the ranges and then you make like a tree. But then yeah. So you have drawings of almost the same thing? Okay. That makes me feel like we're on the right track. That diagram is the thing? That's it? All right. Well, then we're close. We're very close. We've hit the max depth. We need to we just need to do one last check onto the seed ranges and then we should be, I don't know. So let's get a new local variable called seed. We're gonna pop this loop inside of this loop. Seeds. Seed. Seeds. You just wrote a brute force solution. I was pretty confident that this wasn't gonna work in Bash, but maybe it would have. Okay, so now we have our seeds inside of our ranges, and we're gonna do a range comparison, range intersection between range and seed. Oh no. None of them resolve. Oh no. Oh, that wasn't supposed to happen. Do I have it backwards? Do I need to do seed range? Okay, now it's printing stuff. 62. Wait, I don't know which of those is the right answer. 62, 62, 4. I guess it would be... Wait, oh wait, huh. How do I figure out which one of those it is? Is it just 62? No. It should be the minimum. It should be the first one that comes out. I don't know what the location 46. Uh-oh. Uh-oh. Do we even have? Oh no. Oh no, wait, but these are hold on. Everybody chill. So if no wait. So it wants to know the lowest location number. So we need to run it back through? We need to basically run it through part 1. Okay. Uh, let's what happens if we put 62 through part 1? Uh, P1 56. That's not the right answer. Stand by. Are any of these right? Wait, what? Wait, why didn't that? Oh, because it's giving me the lowest number. Oh, but that's not it. Oh, 56. Oh, what have I done? Hmm. Maybe we should do it in the reverse order. Like we go top down instead of bottom up. I'm confused. Oh, I gotta make sample 2 a dependency. Reverse the binary tree. I'm trying, man. What number? Okay. In the above example, the lowest location number can be obtained from seed number 82. I don't have that on my bingo card. It is in this range. Oh yeah, don't worry. This is I'm feeding this into part 1. Maybe we should just brute force all of these ranges that we get at the end. That feels weird. Cause it should come from the first hit. That was the whole point of this exercise. was that we do, unless our inputs aren't sorted anymore for some reason. Does that fix us? No. Still the wrong range first. Right? 62. No, it's seed 82 is the right answer. Still way down here. Maybe I got that backwards. Oh? No. Still second in the results. Sure is that one. Ooh, wait a minute. I did a thing that I wasn't supposed to do. Because I was guessing. So this is lazy. All right, we have different numbers that are wrong for different reasons. No, we're getting nowhere with this. I wonder why. Let's bring back printl. Printl was a good idea. Okay. Let's follow the thought process here. Let's follow the computer's brain. So we're starting off. Let me get a different color. We're starting here. And then we go up to here. We go to 93.57.4. 93.57.4. Which I think is this range adjusted. But no. Because 4... If it went to here, then this number would be 93 would mean 93 would mean it went up by 12. But this minus 12 is 7, not 4. Do we have something that's not local that should be? We can make everything in here local. AD, ASAL, BD, BS, BL. Change. I feel like it's something's missing a local. Maybe not. So where does this 4 come from? Yeah, it is detecting. Where the heck does this 4 come from? If it is BL equals BE minus BD plus 1. I guess we can technically tack more information on the end of here. So we could put a BE here, and no, we can't, because now 125 is broken. Oh. Oh. I don't know. Something wonky is going on here. Oh, shoot. One and two. '93, 4. Hmm. Okay, 93 and 93, 90 on 4 don't intersect. These two don't intersect. Then we're trimming the start and the end of this range. 81, 45, 19. 81, 45, 19. Oh, that's how it goes down to 4. Because it gets clamped. Yeah, maybe I should look at the example. Yes, we go to 93, 57, 4. I'm with that. And then we do the thing again. We map 57 onto I don't know, one of these two. '57, 4 would hit this one. Like 57, 64 or 4, that doesn't seem right. How do you figure 64, my guy? Oh, wait, this is the next tier. Where does 5764-4 come from? Am I done? I think this logic is working. So 5764-4. Where does that come from? Right now, I'm caught up to how we get to here. Which is this one. But 5764-4 eludes me. So what the heck is this? Is that this one clamped? $93, 57, 4. So 57 onto this one would be an increase of... I feel like this output doesn't make sense. There's not enough output here. Something's not working. Wait, what is that? Is that supposed to be there? questioning everything at this point. It's not good. Like, how do we have whole levels missing? That shouldn't be possible. This doesn't make sense to me. Brain fried? Yeah. But how can it get down to a deeper... Unless it just stopped here. No, but what are these top level fucking unindented things? Right? Like, where are these coming from? Is this the issue? It's maybe an issue. No. Okay, there's some that are still not indented. Something is printing without me realizing it. Oh, it's these guys. These are like the final output. I see. Uh, what? Oh, wrong one. Ah, that's dumb. Do we not want to cut it? No, we do. We want to climb the tree and only find ones that are... Yeah. And we end up in this bucket. But that's not the right answer. But why is it not the right answer? Oh. Oh. Oh, this is tricky. This is good sample input. All right. So let's review. I know why it's broken. Oh goodness, I know why it's broken. This is very exciting. So, in the above example, the lowest location number can be obtained from seed 82, which corresponds to soil 84, fertilizer 84, water 84, light 77, temperature 45, humidity 46, and location 46. Now, let's review. Our ranges for humidity to location start at 56 and 60. Notice that neither of these ranges include 46, which means there's a whole range of numbers that we're not considering from 0 to 56. And we need to add that range. We need to do the same hole filling algorithm that we did for all of the other ranges to this very first one. This is very exciting. We have a path forward. So how does this paving shit work again? Yeah, we have a pointer. We go over the very good, very good. We're only going to do this to the last level of the tree. Just kidding, the first level of the tree, because we already attacked it at this point. If I equals 0, Oh boy, it's fun time. Thanks for the follow. Oh boy. So, what do we do if it's fun time? Um, we echo level tr. Great. These are our ranges. Uh, we're just gonna call it fun. Echo the fun. Okay. Local read fun. Okay. If pointer less than AD, what fun. And then we'll do pointer equals. Okay, also make pointer local. AD plus AL. Okay, and let's see what fun ones. Incredible. We're having so much fun. Instead of this, we're gonna say pointer, pointer, AD minus pointer. It's my first time in AOC. Does it get worse? I believe it does. I'm running out of variable names, so we're just gonna call this one well, hold on. We gotta do a little bit more pastes SD this. Oh wait, we could have done that here too. Somewhere. Yeah, this one. Fine, whatever. Short stream, haha. Okay, wait, where were we having fun? Right here. This is the fun. $55. That's not right. That's not right. Oh no. No. Ooh. 55? What'd you call me? It did say 82 down here. Eventually. Which is the right one, right? Oh no, wait. Yeah, 82 is the seed number. Oh wait, what? 55? Oh, that is what we had before. Maybe the real answer is we just try each of these numbers through P1 and see if we win. Real answer is friends we made along the way. Let's adapt to Let's just try. mm, Let's try this on input and see if it even completes. It was pretty slow, but it did complete. Okay. I was getting heap overflow. Okay. Let's let's see if part 1 can save us. Oops. No, so we do seeds, paste, paste. I don't think this is right, but I'm gonna send it. Oh my fucking what? The fuck? Well, yeah, I meant to do that. That was I don't know. They just make these too easy. I think it's just just a little bit too easy for me. That's all. Uh, I, Chat, I don't know what just happened. Did uh-huh. Okay, how are people doing on this? Wait, how do you see the not the leaderboard, but like the just like the stats? Yes. Oh goodness. People are not getting the part 2. Rough. Each wait, so gold star indicates that they have completed both parts. Gotcha. Just sent it. I don't know either. I need to, because it doesn't actually. I want to make it actually work. Um. So what do I want to do here? First, I want to commit this. Just so we don't lose the thing that won. Then I want to revise this so that it actually does the whole part 2 instead of requiring that weird manual step. And then we'll make a then what we're going to do is we're going to take this. We're going to call this we're going to call this My Lucky Picks. Cuz it kind of felt like we were picking lotto numbers and then we just nailed it. And I don't really understand how it worked. So, but we're going to trust the process. And we're going to grab the input dot txt. We're going to go into sed. Do I want to do this with sed? How do you do, like... Let's comment this out. Tail +1, I think. Prints out everything after the first line. Nope. +2? Yeah. So we're going to do +2. We're going to echo... seeds, My Lucky Picks. This is a new function called solve. Data. And then the final answer is calling P1 and giving it the solve data. Wait. That should give us our answer, I think. After a short pause. Yeah. Yeah, okay. All right, that's my solution. If you have a problem with it, take it up with Twitter. I don't know. How long does it take to run? Time. Okay, so let's check P1. How long does P1 take to run? Okay. 0.4 seconds. P2 takes a little bit longer. $12 seconds. 12 seconds for Bash for this problem? I'm quite pleased with that. You know, I don't know if it works for every input. I'll be honest. It probably doesn't. I think we got lucky here. Does it even work for the sample? Let's try it on the sample. Let's say file equals sample. Oh wait, I want to do this in P2. File equals sample.txt. Ambiguous redirect. Good call. I'm a little bit exhausted after that, so 46. It does get the right answer on the example. I genuinely don't know how. Yeah, we wrote like 200 lines of Bash and it does the thing, and I'm not gonna question that. That's yeah. Let's get rid of our debug statements. Actually, let's see how small is it actually. We don't need debugs. There's no bugs to D. Perfect. Under 200 lines. Let's change this to I don't know, narrow ranges. Or find good guesses. We could just do this. Put this all in here. Make sure it still works. Oh, yeah. Oh, yeah. They just make these a little bit too easy. Only took about 4 hours. What the fuck? I'll link the solution in chat if anyone wants to try and understand why it works for me. That would be great. Because I'll be honest, I kind of just was ready to give up, and then it started working. I don't think I'm built for this. Yeah. He gave up? Oh no. Well, I mean, did you at least get part 1? I feel like there's going to be a lot of days coming soon where I'm only able to get part 1 after this. Because this was like an exponential increase in difficulty. That's good. Alright. Surely there's somebody else streaming Advent of Code that we can go bother. Is QV still doing it? It would seem so. Alright, he's much smarter than me, so he's probably gonna figure it out faster. But let's all go laugh at him because I figured it out and he hasn't done it yet. They're so much harder than the first days last year. I know, right? All right, thanks for hanging out, everybody. Have a good
I'm
night.
thinking about right now is like overcomplicated though, is the thing. Maybe we should go for an easier solution first.